Welcome to Bioenergy System Overhaul Incorporated. Today we are looking at the case of the EU policy advisors who have asked us to look at whether it is more optimal to produce bioenergy from rapeseed or from chicken manure. System Overhaul has looked at this process and has first looked at, okay, what does the rapeseed process look like? We constructed a flowchart and we've similarly constructed a flowchart for the chicken manure process, as you can see here. So what are we comparing? We are looking at the environmental impact of producing rapeseed, electricity from rapeseed versus chicken manure for producing 100 kilowatts in electricity. And here we are looking at the global warming potential. We are assuming for our model that the chicken manure production is happening in Northern Europe because that makes it easy to compare to the rapeseed, which is also happening there. And we are also making some changes to the original rapeseed LCA model, which we considered incorrect. As we will see, the system performance of rapeseed compared to chicken manure has a global warming potential of about 100 times higher. So of course we ask, where does this performance difference come from? Well, let us look at the processes step by step. So first, what we look at is for rapeseed, we look at production. This process we've allocated economically to better reflect the value. And here we see that a lot of the rapeseed emissions are coming from, but in the end, the rapeseed global warming potential was of course really small. For chicken manure, we are not taking production into account because chicken manure is a waste and not a good. So there is no production because there is really no use for chicken manure, and if it's useless, it's a waste. So then we look at transport. We would expect a lot of emissions from the transportation process, but really there's only very little, and the CO2 is also negligible. Even for the rapeseed there is some, and also their transportation happens twice, whereas only it happens once for chicken manure. So not much there. So in storage, also for rapeseed, not much. Even though it requires electricity, no significant contribution. For chicken manure, we make some assumptions that the waste, that the chicken manure turns from a waste into a good during the storage process. We allocate this process physically because it's a waste turning to a good. We now need to allocate. We do it physically because it's most appropriate, and we cannot really put a price in a waste. And here we see that the methane coming from this process has significant contributions. For drying, also for rapeseed, no significant contributions, but for chicken manure there are some significant contributions in the form of CO2 and methane. And last, almost last, for the combustion, this is different for the rapeseed because here we are co-firing with oil and natural gas, but still no significant emissions. Perhaps because there's a mistake, but most likely also because this is just negligible. For chicken manure, we are combusting, so we are assuming some values to make some calculations on the CO2 biogenic that comes out in the heat emissions, but these both do not contribute to the global warming potential. What does come out is ashes, and we have the option to use these ashes later as fertilizer. But for the purposes of our analysis, we are just considering this a waste flow. Overall, also for combustion, not a huge, no contribution actually whatsoever to our global warming potential, which might come as a surprise to some. So overall, what we're looking at, we see again what we had seen at the beginning is that the chicken manure has a global warming potential that's about 100 times higher than that of rapeseed. And then we could say, like, well, do we not need to make electricity from chicken manure at all? Well, one thing that goes into consideration is that chicken manure is a waste. It's something that we already have and that we could then maybe just turn into something useful, whereas rapeseed is something that we need to actually go out there and produce. As we saw, this production, as we will see in the next slide, for rapeseed is also really the biggest contribution to the global warming potential, and it's happening on land that we could also use for valuable other processes such as food production. So how could we perhaps then optimize this chicken manure process where the drying and the storage are really the biggest contributors to the global warming potential? One way to optimize that we are proposing is to use the waste heat from combustion for the drying process. And if we do that, we actually get a huge improvement in our global warming potential, as we can see from these results, from 145 to 83. So that was all our analysis from the bioenergy system overhaul. Thank you very much for listening. I hope to see you next time.